Hey everyone, welcome back to South to Sal. My name is Heem, that's Nick, and today we have a special guest with us. His name is Hong. You want to introduce yourself real quick?
For sure. Hi everyone, my name is Han. I'm a current undergrad in Case, studying biomedical engineering. I was in the same lab. That was the previous guest, Ryan Hall. I'm in the same lab with him. I'm currently his undergrad.
Nice, man.
Yeah.
Nice. So, you know, you said you're at Case. Where are you from? Like, what high school did you go to? How did you get into science? Like that kind of stuff. Why don't you go ahead and share?
Yeah. So, actually, I started study abroad. I'm from China. I started studying abroad pretty early. I came here when I was middle school. I was back in Florida, studying in a school called North Broward. I was there. I found my interest in biology actually, but then when I moved forward, I had a uncle. He was a postdoc in cell biology actually.
In
Well,
Florida?
No. He was in Harvard.
Okay.
That was a different story. But like he recommended me saying, no, you can't just do pure biology. Like it's hard to get into industry.
Mm-hmm.
So he recommended me do something different. So I was looking into it. I was like, why don't I do biomedical engineering? So I ended up here, applying to Case. I got in.
Nice.
Yeah.
And why biomedical engineering? Because that's not fully biology or something, or chemistry or something.
Yeah. So eventually if you do engineering, you end up having all those contents in your major, but mainly because I was interested in getting like a MD and stuff. Chinese parents,
Yeah.
very Asian stereotype.
Oh Lord.
They hold you up there. They want you like, oh, you're gonna be a doctor.
Yeah, okay.
But then on their list, saving people was on the bottom of the list. So
Oh,
yeah.
Lord.
Why you want to be a doctor? Now that's
yeah.
different,
So I kind of got pushed there. But then I was thinking, so if I want to be an MD, why don't I join biomedical engineering? And at Case we had a physiology class, and that's one of the common class that the pre-med students in Case they took. So that's why I'm kind of getting enrolled in there. But throughout the course, little change of mind. I want to stick with biomedical engineering.
Now, Florida to Ohio. How's the weather? How's the change? How's schooling? What do you find any differences? Do you feel like?
Well, biggest difference would be it's colder. It's definitely
Yeah.
colder. I gotta enjoy the cold weather. Well, I thought I was gonna like snowing, but after spending here like 4 years straight, I can't say that right now. But
Snow is no fun.
Oh,
People
yeah.
who have not experienced snow and think that snow is like this beautiful thing.
Oh, wow,
No,
yeah.
it's annoying. It's wet. Makes everything slippery, and no one knows how to drive in it. Even if you
Yeah.
live in a place where it snows, it could snow all year round. No one would know how to drive in snow. So I'm
Yep.
sorry. I just had to make that comment.
No, I don't know. I did have the fantasy of having snow around me.
Uh-huh.
There's no truck drivers, no SUVs. Just a beautiful snow day, can build a snowman or stuff. No, that's a dream life.
No, that is a fantasy.
Yep.
But you said your uncle was at Harvard?
No, yeah.
Oh wow. In cell biology.
Yeah.
That's really cool. That's really cool. So having that kind of influence, your parents want you to be MD. They want you to go MD route. Your uncle at a very, very well-known and high-up institution. How would you say that affected your outlook on biology, and how that affects your outlook now in biomedical engineering?
Well, see, definitely my parents pushed me a lot. Like they want me to get better, do more studying.
Mm-hmm.
That's one of the things why I'm working so hard at current stage. But for my uncle, it's more like he was like more like the pioneer to me, because when I first started, study abroad, I didn't know biology at all. I'm like, what is this? And I learned cell. I do this, and learned a bunch of stuff, and end up, I'm interested in biology. I also like chemistry too. So like, try to do pure biology, and get some comments from him, and mostly suggestions.
Yeah.
And here I am.
No, that's really cool. I think one thing that's important and that a lot of people might not understand is that a lot of people who take science classes just view it as a science class, right? But I feel like the three of us sitting here in this room, we've taken the science classes, but we've learned to love the art of biology, right? Science is, very much artistic as much as it is technical, if that makes sense. Because in the lab, we take organic chemistry, for example. You have 50-step synthesis, a 50-step synthesis to go from one molecule to another. But then there are people who are able to do it in 45 steps because how they can use their hands and combine it with their mind and then save themselves time and money and energy, basically. And I think that when you find your love for the art of biology or chemistry or science is when you really start to fall in love with the science. It doesn't become a science or a chore anymore. It just becomes like part of you. I don't know. That's how I feel about biology. I really fell in love with it in undergrad and even in high school. And it no longer feels like a chore when I think about it. Like I just really like thinking about it. So I don't know if you agree, but I just thought I wanted to add that.
No, I totally agree. But like, my experience with biology was, I loved it. I love every part of it. Besides, when they it's usually like the third or the fourth chapter or the beginning of the book, ask you to memorize what Darwin said. I feel like that was a literature class.
Darwin?
Yeah.
Oh, okay. You
Wait,
don't like that stuff?
Some evolutionary biology.
No, it's not even that. It's like they quiz you, they test you on, let's say, what year did Darwin found this? And I'm like,
that's history.
The history of it.
That's not biology. That's,
you don't need to know that.
And you don't need to know that. Like, that's great. Like, when I learn, all the processes involving like chemistry and stuff, that's fun. Like even like how animal distribution across the world, all that, it is fun. But like, it always destroys your interest. Like at the beginning of a chapter, it quiz you on, oh, so what year did Darwin did this? And
Who cares?
Yeah.
Right? No, I think that understanding the history of science is important, and I think that it's really cool because, like, I am not one who loves memorizing dates for like history.
Yeah.
Like I have friends who are history nuts, and they absolutely love studying history and memorizing dates and wars and all this stuff. And I'm like, that's boring. But I think it is important to see, and to understand where all this science has come from. And I think it's cool to watch how, as the timeline keeps moving forward, more and more important discoveries keep just getting closer and closer together. You know what I mean? Like we hit like evolution, and then you waited 50 years, and then something happened in chemistry, and then all of a sudden you hit like early 1900s into the late.
Now every 5-10 years.
Now every 5-10 years there is something, and we are right in it.
Yeah.
And I think that's really cool. So to understand how fast science is moving now, I think that might be a little bit what the history is trying to poke at. But okay. Enough. This is not my episode. This is Hong's episode.
All right, Hong. Let's talk a little bit about your journey so far at Case.
Mm-hmm.
So, how did you find Ryan? When did you find Ryan? How did you know Ryan was working in Nanoparticle Lab?
Mm-hmm.
How did you find Dr. Lou? How did you know it was nanomedicine part of BME you wanted to work with and not biomaterials?
Okay, so
all of that stuff.
It was really more like an accident that ended up with Ryan. So, when I was a freshman, it was the spring break. At the end of it, COVID appeared, spread out in America, and most of my friends, classmates, they all went back home. But my parents were like, no, you stay in America. Don't come back here. It's even worse. So I got stuck here alone.
Oh, no.
So I was like, since I got so much free time besides my classwork, why don't I find a research? That's one of the requirements for my graduation. I need to get some experience in lab. So I went in and searched. I talked to my academic advisor. He was like, just go to case.edu, start just searching on there. Like, the topic you like is, because I signed up for nanomaterial on biomaterial track for biomedical engineering.
Oh, okay.
So, and then I wanted to do drug delivery. So I just went up and searched nanomaterial, drug delivery. Dr. Ziarlu was the first professor that actually showed up on there. And I just started writing him an email. I was like, hi, Dr. Lu, my name is Han, yada, yada, yada. I really want to join your lab. And he was like, our lab is currently full. You want to wait a little? And I think it was the end of my second year. He said, hey, we got an open spot. You want to come
So
in?
you waited a whole year?
Uh,
Because you said end of freshman year COVID happened.
no,
right?
I actually started searching when I was junior. No,
Sophomore.
this is sophomore. Yeah,
Okay.
Got you.
and then it took a little while, and then I think it was around winter break or something. I started writing emails to all the professors. Dr. Wu was actually the first one that replied me.
Nice.
Dr. Lou's awesome.
Yep, Dr. Wu was
Wow.
awesome.
And like, so you found Dr. Lou first, and then did he partner you with Ryan?
Yes.
Okay. So the PI did it.
Yeah.
You didn't find Ryan first.
Yeah.
Okay.
So, and I went in, Ryan kind of showed me around, sent me a couple papers, did all the trainings and stuff, and I ended up here.
Nice. Do you like what you're doing?
Oh, yeah, definitely.
Yeah.
Do you have any plans for graduate school or,
Oh, yeah.
kind of, where do you see yourself in
So
5,
right
10
now,
years?
yeah, so I'm not currently applying to Dr. Lu's lab right now.
Nice.
Plan is get in,
Yeah.
hopefully, get in and, get a PhD degree. And I don't have any plan from there, but we'll see.
Sounds like your plan is to get a lab and continue your research.
Oh,
I
yeah.
think that's really cool. I know the PhD route is very challenging. It's a lot. It really is a lot. But you know what? It takes passionate people to become PhDs, and just from sitting here for the last 10 minutes listening to you, I can already tell that you love the science and that you're really excited about it. So I think that PhD is going to be a good route, and you should get in. I'm
Thank you.
right would. How long have you been in Dr. Lou's lab?
Oh, a year. Yeah.
Nice.
And you can't sleep on Hong's pipetting skills.
Yeah.
Dude, Hong is so fast. Because we worked like pretty much every day during the summer.
Oh, yeah.
So like, dude, Hong would be like, if you had 99 wells, he'd be done. Hong would be
You don't
like,
have a multi
he'd be
channel
done. Dude.
pipette?
Oh, we do, but it was never calibrated.
Yeah, it doesn't
Oh,
make sense. I'm
yes.
saying that he does it like, even if you have to change pipettes between each one, he goes,
Yeah.
and then gets a new one, and he's fast.
See, the trick of it is get trained of it, because when I joined the lab, it was during COVID, so all the the research of like pipette tips and stuff are prioritized for
Yeah.
COVID checks, and even though our lab we order like a bunch, but like it never arrived, and we just write email to team to buy. They're just saying like, oh, you're not prioritized. They are, so they're not shipping your orders. We were at one point we ran out of 1 mil tip. We only have to use the 200 ones,
Mm-hmm.
and to passage all the plates and stuff.
So you have to do everything 5 times.
Oh, yeah.
That's
Like every step.
horrible.
Yeah, or stuff. It's only due to COVID, but from there, you got the practice of your pipetting skill, just your hand. Just
Yeah.
you keep going.
I learned a lot about cell culture from Hong because I would see him do it a lot. Ryan would come the first couple times. He'd come and show me the procedures for everything, so I'd write it all down. But then, like, if you run into any problems, Hong would know from his experience just, like, how to problem solve and everything,
Right.
And, like, I enjoyed cell culture. I really did. Like, adding trips into the plates, seeing all the cells literally come off,
Yeah.
and then moving them and stuff. It's like, I liked it.
Yeah.
I enjoyed it.
See, we'll have more fun stuff right now. I think Ryan got a new Mach 1, Mach 2 cells. There's mice cancer cells. You have to make a special media for it.
Oh, you do?
Oh, you do. And tell you what's funny. We ran out on the electropipette, the 25 mil ones, and the component of the new media was, I think was like something, what percentage of IMDM. It was it's not
Oh.
DMEM,
Oh.
regular media. We have to do another nutrition factor, it was F12 something. That's a nutrition factor for the cell. You also have insulin.
Instead of FBS?
Oh yeah, you're
Oh,
gonna.
you still this is all like tiny micro parts.
Oh yes, oh yes.
That's so specific.
And because it actually goes out of date, like it just expired real quick. So every time you only make like 50 ml.
Oh my god.
Yeah, it's a hell of a lot of experience.
Wait, why?
missing
That's interesting. Like you would need even the little things, that extra little things for different cells.
Yeah, so like the cell won't grow. That's basically it's more like a conclusion because that's what we have been told from the lab that given us the cancer cell. We received it, but according to Ryan, he has been told that it needs all those components to make the media. Or if you don't do it, the cell just won't grow. They're just gonna die out right away.
That's crazy.
Interesting.
Yeah.
Yeah. Culturing cells is a whole new world
Yeah.
of there's so much that goes into just growing cells on plastic. It's insane.
See, I feel like especially like biolabs, like growing stuff, whatever you grow in the lab, like besides cancer cells, sometimes
Right.
People grow like those bacteria and stuff, and they form certain things.
Right.
You go to like home, like some people never clean their fridge. You open it up, you got better bacteria clumps
Exactly.
than you grow in your petri dish in the
Seriously.
lab with an incubator.
That's interesting.
Yeah, no, I lived in a house with 2 roommates, and I've definitely seen better cultures in my fridge. Luckily, they were in Tupperware, but
No.
Those bacteria had a lot of food, a lot of media.
they had a lot. To
Perfect
eat.
growth condition.
Exactly.
No, I'm kidding.
But like they're in the fridge.
Exactly,
But
and
those-
they're like resistant, man. Like
I know.
the cells in the lab need like perfect CO2 levels.
Oh yeah.
37.5 degrees Celsius incubation, at least a week to see any growth.
Mm.
And then you go home and you're like, that food's been in there for 5 days. It already has mold on it. Nice. So,
Yep.
no, and I think it's cool. I think it's funny because, we talk about in the lab all the time. This stuff happens naturally all over the place.
Oh, yeah.
Whether it's in your body or in your fridge or out in your backyard.
But that's
biology is
uncontrolled.
so much alive.
That's uncontrolled growth.
Exactly.
Where we
Yeah.
are trying to make something
I
like
know.
controlled, a controlled environment, consistent results. If you run things in triplicate,
Yeah.
obviously you need like the environment to stay the same.
Right. Oh, triplicates. How fun. How fun. Do you guys run any PCR in your...
Oh yeah,
I was
definitely.
gonna say,
Yeah.
have to. And those pipetting skills come in clutch during PCR. You
Yep.
need really good pipetting skills in order to make sure that you're mixing your CD in it and everything. So,
Yeah, this is something I learned from my mentor Ryan. Some skills he has shown me, and that make my life actually easier.
yeah.
And at a point, he trusts you enough for you to do the work. He would just give you like 2 plays of PCR plays or two of those. He once gave me like 496 well play
Mm-hmm.
for doing the viability test. That was insane. I gotta do 496 well play once. I gotta plate them for the first time. Few days later they grow. I gotta replace media, wash, and then no, actually I have to wash and treat, and afterwards I gotta wash it after 24 hours.
Yeah.
The next day, and then the day after start imaging. I have to make solution pipette it into
Wait,
old.
496 well plates.
Oh, yeah,
And
490.
you had to wash them.
Oh yes.
It's so fun.
Oh,
Oh,
no.
yeah. Because we're using a cisplatin. As you
Oh.
know, you have to wash the excess drugs out
Oh,
so it doesn't affect the imaging
yeah.
and stuff and the reading. So you have to use PPS, wash it out, and then you replace with the imaging media. 4 plays.
Oh. But I like everything they do in the lab because,
Oh yeah.
When you make the nanoparticles and stuff, it's really interesting and it's like a bit of suspense to know, are they the right size? Are they
Yeah.
too big?
Yeah.
Are they too small? Did I make a good batch this time?
I think once you get used to like a protocol, and like you might be able to speak to this, but like pipetting, maybe not for hours, but pipetting a bunch of stuff, it's almost kind of therapeutic after a while. Like,
Yeah.
you just kind of get in the zone, and you're just like, when I'm in the lab, I have like my AirPods in,
Yeah.
and I'm just listening to music, and I'm just like laser focused. Like no one could
Yeah.
ever knock me out of this, and like they came and hit me over the head with a textbook.
Yeah.
Like that's how focused I am, and I get like almost like a high. Like when I'm done, I'm like, dude, like I just kicked butt doing that, and it felt really good.
Yeah.
And then I get my results back, and maybe my triplicates aren't as tight as I want them to be, but it comes with practice,
Yeah.
right?
It'll come
And
practice.
if you plan on ever working in the lab, if you're watching and you ever plan on working in the lab, the first 3 months or 3 weeks to 3 months might be really rough because you're learning protocols, you're learning where everything is, you're trying to just kind of wrap your head around everything. But once you get in like a good like flow state and you understand your role in the lab, you really do learn to enjoy it.
Yeah.
And I think that, so you've been in this lab for a year, and I mean, I'm sure you go in, you don't even have to you wouldn't even have to open your protocol anymore. You can just go in and do it,
Yeah.
right?
Yeah.
And like at that point, it just becomes like second nature.
Yeah.
And I think that, as much as people who are taking science labs, chemistry labs, biology labs in high school, or if you have them in high school, or you're taking them in college and undergrad, you go in and you have this long protocol, and your teacher, you don't know where everything is, and like it seems so hectic. But once you get into a lab and you get acclimated and you get to do your one thing or your two things, you do learn to really, really like it. And I think that once you get comfortable, it becomes fun, and then you can start talking. Then you can start talking to people, and like if you know what you're doing already in front of you, you can start making friends, and like you can talk about everybody's day and all that kind of stuff. But you got to make sure that you know what you're doing. So
exactly, and as you mentioned, like school. I feel like my experience in the lab, like actual lab that you actually do research lab, is completely different from your course like laboratory experiments.
Absolutely.
Is from according to just my experience from high school to college and stuff, they jump over a lot of steps for you just to save time because, it's first time you open up the protocol for undergrads. They're not guaranteed that you have the experience to accomplish all this. You might fail, and some of the equipments are important. They can't risk it. So at this point, they kind of just jump over a couple important steps that you actually have to get experience on to be in a wet lab,
right,
or so. But due to all those costs, they actually jumped it over. So you end up maybe like just touch the pipette for a couple times, and then that's the finish of your lab.
Yeah.
Like they give you pre-lab quiz, you have to write a lab report, but you actually in the lab, all you do is grab the pipette, do a couple steps, turn it in. The TAs will give you the result, and you go on from there.
Yeah.
It's not representative of real.
What real science is. And even like in my undergrad where I went and had like small basically one-on-one labs, now that I work in a lab here, I can definitely attest to you definitely skip a lot of steps. And I mean, we ran a lab in virology where we literally set up 96 well plates and ran the PCR, and doing it by myself is like totally different than anything we ever did. And like I can still say I ran PCR in undergrad, but it is not the way that everybody else runs PCR. It's just different. So I think that is important for people to understand, especially if you're interested in going into a wet lab.
Yeah.
You gotta understand that.
All right. Last couple questions for you, Hong.
Yep.
Let's talk about nanoparticles once again. So, what do you think about nanoparticles in the future of medicine, and what, from your experience in the science, just hearing Ryan and attending all the lab meetings, right?
Yeah.
So you get to know what everyone does in the lab. What disease do you think nanoparticles works for best, or what kind of things are nanoparticles good for?
Well, so nanoparticle itself. Well, because we use nanoparticles as only carriers as the packaging, but there are many different ones out there, and specifically for our lab, Dr. Liu used ECO as the carrier for cancer uptakes.
Yeah.
But just recent example, the genome therapy we just received for COVID, the vaccine, that's mRNA vaccines.
Yes.
Also cover, I'm not sure what packaging they use, but it's also nanoparticle packaging. They just package, and the benefit of it is easy access, and you can high production of the nanoparticles, and because you have experience in the lab. What we do when we kind of just make the nanoparticles, and then after we dilute our mRNA drugs into the concentration we want, we kind of just mix it and shake it, just to make sure everything encapsulate, and and you do DLS and all your zeta. You have to see your charge and particle size just to have a guarantee on your product. Yeah, so I see it's a bright future for mRNA and nanoparticles because, you know, right now, the vaccines have been tested on people. We're all alive, so that means, and it's functional.
It's not a microchip.
Yeah, so it's been shown that somewhat functionality of itself, and and I feel like nanoparticles will be accepted or applied onto different kinds of medicine. Right now, it's only on vaccines, and somewhat treatment for cancer.
Yeah.
But in the future, nanoparticle packaging itself, I believe it can be used on multiple diseases or stuff.
And I like it best because you can use it on every kind of person. When you do some sort of cell therapies, you have to do blood type matching and everything. Yeah. So it becomes a little difficult in that sense because you can't really just give it to anybody. Nanoparticles is like off the shelf,
Yeah.
You can put some mRNA in a nanoparticle because it's lipid based, so it's just an oil. And this kind of oil, if somebody's not allergic to the contents of a lipid nanoparticle, then you can give that treatment to anybody. And I think that is just like the best thing about nanomedicine.
Yeah, we're continuing to look for that silver bullet that everybody can get that will either cure one or multiple cancers or diseases or something like that. And I think that going back to like the mRNA stuff, how it was present before COVID, but it really hit a high during COVID of usage and attention in the news. But I think that mRNA vaccines in hand with like nanoparticles could be monumental for the scientific community and medicine in general. And we could really start trying to cure diseases and especially viruses that have just plagued humans forever. Like, there's not a vaccine for hepatitis C, is there? I don't think there is.
I don't know.
I don't think that there is.
Don't think so, yeah.
Yeah, and so imagine creating the first nanoparticle that contains an mRNA sequence that is a cure or a vaccine for hepatitis C or hepatitis A or Hep B, that kind of, or Hep E, and you go to third world countries where, water quality and all that kind of stuff is bad and it runs rampant. I just think that application of these nanoparticles is like so important. And then we can look into cancers, right? Because cancers really, viruses are, here, cancers are like way up here in complexity. Yeah. So I think the nanoparticles, like you said, have a really, really bright future, and I think that they're super, super interesting. So,
cancers are difficult because they have mechanisms to evade the immune system.
Yeah.
So they are smart. They react and they think. Whereas other things, they just kind of come into you, and then you can solve them. But cancers are from within, problem from within.
Yeah. I mean, a virus that kills something, technically the virus failed. The virus is supposed to keep the host alive as long as possible and be transmitted to as many things as possible. So, in that sense, when you think about how it's constantly, trying to circulate and trying to get into new parts of your body, and especially when they find a home in, Hep C in like your liver or, any other place in your body with any other virus, having an mRNA vaccine that has, let's say, a 3-month half-life where your immune system is fully turned on and searching for that virus and looking for those, antigens that are being presented by macrophages or whatever and by healthy cells. I think that'd be really, really cool to start pushing in that direction. And keep the cancer research. Cancer research is important, but I think hepatitis and those kind of viruses need a lot more attention than I think that they're getting.
Yeah.
So.
All right, Hong, for anyone that wants to get into research, do you have any words of advice for them? And if maybe try recruiting some people to CASE?
Oh, yeah. Definitely, find yourself into a research lab as early as possible. That's, especially your engineering, what kind of engineering you are, get in research early, get experience of it. Whatever your plan is, you want to do industry like right after you finish your undergrad, or you plan to do graduate school, it's always helpful for you to get in the lab, get some experience, get a few recommendation letters. Yeah, mostly the most important part is the experience, and then you could get some recommendation letters, helps you out a little, and one thing I think Case is really good is there are a lot of open opportunities, and because since me I'm a biomedical like in the biomaterial track, some what I learned I can actually apply to my lab and everything I do. Especially right now, I'm taking Dr. Lu's class right now. Is mostly relearning whatever I've been told by Ryan one more time.
Are you gonna take 426 next semester?
Oh yeah.
Oh, so you might be in his class.
I'm not taking that.
Oh, you're not taking anime?
I'm taking biodesign.
Oh.
You guys would have had the same class.
I told you before the podcast why I took biodesign. I'll tell you after too.
Okay, whatever.
But I think also one thing when you're looking for a lab is don't just join a lab to join a lab. Join something that you're interested in, and join something that you see yourself being in there for a while. Because one thing that, primary investigators hate is when they bring on an undergrad or even a new graduate student and they come in for 8 months and then they leave and then a year later like, can I have a letter of recommendation? And they're like, sure, but you need to find something that you really think, find a lab that you want to get your PhD, that you might want to get your PhD in.
Exactly.
You should have that level of passion when you're looking for labs and looking for a PI because, and sometimes it just doesn't work out.
Yeah.
Right? And
exactly.
that's totally okay, but don't go in there, work for 9 months and be like, okay, time for my letter. Time to move on.
Yeah.
So find something that you're really, really, really interested in and passionate about. And I think that you won't want to leave after 8 or 9 months. I really believe that. So, all right. Well, we've been going for a little bit.
Yeah.
So I wanted to say thank you for coming on. We appreciate any guest that is willing to come on and share their scientific experience.
Thank you guys for having me.
Yeah, no, it's fun, isn't it? It's fun. We just sit here and talk is what we do. We talk basically to nobody. So, Heem, do you have anything else before we end this one? Or?
Not really.
Hong, you got anything else?
No, I think I'm.
All right, perfect. Well, we want to thank Hong for coming on to Cells to Cell. Go ahead. Remember to we should have said this at the beginning, but hit the subscribe button, hit the like button, share it with your friends, your family, anybody who who might be interested in this kind of stuff. But that does it for this episode. I'm Nick. That's Heem, and again, we thank Hong for coming on. And this is Cells to Cell. See you guys.
See ya.
Bye.